climate change. There's a lot of evidence of climate change. One being the global temperature rising. The planet's average surface temperature has risen about 1.62 degrees Fahrenheit since the late 19th century. This is driven largely by increased carbon dioxide and other human-made emissions. Most of the warming occurred in the past 35 years, with the 5 warmest years on record taking place since 2010. And the year 2016 wasn't only the warmest year on record, but 8 of the 12 months that made up the year, from January through September, with the exception of June, were the warmest on record for those months. Another sign of evidence is the warming oceans. The thermal expansion of seawater and continental ice melting leads to deoxygenation and sea level rise. Deoxygenation, which is a reduction in the amount of oxygen dissolved in the ocean, in both temperature increase and ocean acidification, which is the decrease in pH of the ocean due to its uptake of CO2. They both affect marine species and the ecosystems. In the future, many of the ocean life that we depend on will become extinct as a consequence of these actions. More evidence is the shrinking ice sheets. Greenland and Arctic ice sheets have decreased in mass over the past century. Data from NASA's Gravity Recovery and Climate Experiment shows Greenland lost about 286 billion tons of ice per year, and Antarctica lost about 1.7 billion, or 127 billion tons of ice per year, both between 1993 and 2016. The rate of Antarctica's ice mass loss has tripled in the last decade as well. More evidence is sea level rise. The global sea level rose about 8 inches in the last century, and the rate in the last 2 decades is nearly double that of the last century. Some other evidence is glacial retreat, so the glaciers melting, decrease in snow cover, and extreme events such as like hurricanes, natural disasters. Causes for this. One cause is the greenhouse gas effect. Certain gases in the atmosphere block heat from escaping. These gases, such as carbon dioxide, which is minor but very important component of the atmosphere. Carbon dioxide is released through respiration. So when humans respirate, they give off heat, and that's trapped below the atmosphere. And volcanic eruptions also release carbon dioxide. Through human activities such as deforestation, land use changes, and burning fossil fuels also releases carbon dioxide. And humans have increased atmospheric CO2 concentration by more than a third since 1960. Water vapor is another heat-blocking agent in the atmosphere. The most abundant greenhouse gas is water vapor, but importantly, it acts as a feedback to the climate. Water vapor increases as the Earth's atmosphere warms, but so does the possibility of clouds and precipitation. Methane gas is also a heat trapper. It's caused by the decomposition of waste in landfills, agriculture and rice cultivation, as well as manure management associated with domestic livestock. And nitrous oxide, which is a powerful greenhouse gas produced by cultivating soil, especially in the use of commercial and organic fertilizers. Fossil fuel combustion, nitric acid production, and biomass burning also releases nitrous oxide. And another cause is the role of human activity. The industrial activities that our modern civilization depends on have raised atmospheric carbon dioxide levels from 280 parts per million to 400 parts per million in the last 150 years. There's also more than a 95% probability that human-produced greenhouse gases such as carbon dioxide, methane, and nitrous oxide have caused much of the observed increase in Earth's temperatures over the past 50 years. So that means basically saying there's more than a 95% probability that the human-produced greenhouse gases have increased the Earth's temperature. And there are two overall solutions that we could use to solve this problem. One would be mitigation. The mitigation of climate change can be decreased by reducing the flow of heat-trapping greenhouse gases into the atmosphere, either by reducing sources or enhancing the sinks that accumulate and store these gases. The goal eventually would be to avoid significant human interference with the climate system and stabilize greenhouse gas levels in a time frame that is sufficient to allow ecosystems to adapt naturally to climate change, ensure that food production is not threatened, and to enable economic development to proceed in a sustainable manner. And the second solution is adaptation. And adaptation is like adapting to life in a changing climate. It involves adjusting to actual or expected future climate, and the goal is to reduce our vulnerability to the harmful effects of climate change, like sea level encroachment, more intense extreme weather events, or food insecurity. It also encompasses making the most of any potential beneficial opportunities associated with climate change, such as longer growing seasons or increased yields in some regions. And seeing the evidence of climate change and the causes for it, what solution, either mitigation or adaptation, would you guys choose to use?
I would choose mitigation. 'Cause
I think adapting
with the ice melting and a lot of the climate that's changed already, I don't know how we would be able to manage our life with all the change.
I think you'd have to do both. I just do. I don't think there's enough time to
You can't completely,
erase
especially
what's
You
already
have to
happened.
adapt.
living on Earth right now, you can't completely mitigate or completely adapt. You have to do both, especially our generation or anybody living on the Earth right now.